Okay, in this example, we are given that we have two heat reservoirs. So we have a heat pump that's moving heat between these two heat reservoirs. So we have one that's right here, and it's operating at something along the lines of 20 degrees Celsius. And you have another heat reservoir that's at 80 degrees Celsius. And what we're trying to do is we're trying to move heat from one reservoir to the other. So from a hot room, something like Freon, that's colder, we're trying to pump heat from one reservoir to another, something along the lines of geothermal heating or cooling. So we are given the fact that we have two reservoirs, and the first one, the cold reservoir, is operating at 20 degrees Celsius, and then the hot one is actually operating at 80 degrees Celsius. Now what we're trying to find is we're trying to find the efficiency of the pump. And the principle that's really involved here is the fact of efficiency is usable divided by total. Now that's not really a formula, because the formula we're going to use is efficiency is equal to 1 minus the temperature of the cold reservoir divided by the temperature of the hot reservoir. Now one thing is, for this formula to actually work, it requires that these temperatures be in Kelvin. Okay, and they're not right now, they're actually in Celsius. But now remember, in order to convert from Celsius to Kelvin, it's pretty easy. All you have to do is add 273.15. You can actually do that to both sides fairly easily. So now we're going to go ahead and go to our solution. Now that we've converted our values, we can say, alright, well my solution is just going to be 1 minus 293.15 divided by 353.15. Take those, subtract them, and then you multiply it by 100, and that will give you your percentage efficiency. And when you do that, you get roughly 17% efficiency. It's actually something like 16.99% efficiency, but it's roughly 17. And what we got is we got an efficiency, which is what we were looking for. So we can say that is what